Number 83, letter A, find the current through a 0.5 Henry inductor connected to a 60 Hertz 480 volt alternating current source. All right, so we can actually apply kind of a variation of Ohm's law here. All right, so current here will equal voltage over resistance. But now in these problems, when we're dealing with, let's say, an inductor, okay, and this is no longer necessarily called just the resistance. Okay, we can change that term and now call it the reactive inductance, okay, or the inductive reactance. It doesn't really matter which way you put the phrases. But this kind of has the value of ohms, all right? Now, in order to find current here, we have to know two things. We got to know the voltage, and we have to know the inductive reactance. Now, we know the voltage. They told us that's going to be 480. But we don't know the inductive reactance. And therefore, what we have to do is we have to find a formula that deals with inductive reactance. Here it is on the right-hand side. Inductive reactance is going to be equal to 2 pi multiplied by the frequency of oscillation multiplied by the inductance. So wait a minute, we have the frequency, we have the inductance. Oh, goody gumdrops, we can solve, right? So all we now have to do is basically just plug this thing on into the bottom of the formula here. So there's going to be 2 pi multiplied by the frequency, that's in hertz, so that's fine. And the inductance has to be in henries, which that is, and that's all we need to do. So now what we're going to do is, well, before you throw everything off your desk, do 480 then divided by parentheses now, 2 pi times 60 times 0.5, close those parentheses, and voila. We now have a current here flowing through that's going to be about 2.55 amps. And that's it, all right? Now let's take a look at letter B. It says, what would the current be at 100 kilohertz? So all we have to do basically is take this formula, and the only difference now is going to be the frequency. All right. So instead of 60, we're going to plug in a 100 times 10 to the third in there, and then just recalculate. So there's going to be 480 divided by parentheses 2 pi times then 100 times 10 to the third times 0.5, close the parentheses. And here we now come up with a value of 1.53 times 10 to the minus 3 amps. So notice what happens as the frequency increases, the current decreases. Guys, thanks for tuning in. I hope that helps. And if it does, give us a hand if you can. Subscribe, like, maybe even mention it to your classmates. All right? And mention what to your classmates? That we're doing all the problems. We'll see you soon. Take care.